Hey Cassandra, good morning. I'll try to explain questions on Module 2 Review 1. So these are my questions. This is how it looks like. Everybody might have different f of x, g of x. So if you have f of x is equal to x squared and g of x is equal to square root of x minus 1, let's have a look what will be f of g of x. So it will be f of g will be this, and everywhere we see x on f of x, we're going to plug in x minus 5, square root of x minus 5. Then it will be square root of x minus 5 square. This is f of g of x. Now, stop and think here. Because inside function is square root of x minus 5. So then x minus 5 should be greater than equal to 0, right? Because it's an even root. This is an even root. So x minus 5 inside the square root should be greater than equal to 0. Then x should be greater than equal to 5. So this is our first restriction. However, we're ending up with f of g of x here because these two cancel each other, x minus 5. It seems that it is negative infinity to positive infinity, but it is not, right? So domain of f of g of x is not negative infinity to positive infinity, although we're ending up with x minus 5. This is the part that we really need to be careful because we have an inside function which is square root of x minus 5. Whenever we plug in an input, it will first be processed in g of x and then it will produce an output, and that output is going to go to f of x to be x squared. So then how are you going to write that? X greater than equal to 5, right? So you need to write it because you are going to include 5 also, you are going 5 to infinity, and that is going to be your domain, not this one. Not this one. Okay, so this is part 1. You really need to remember, you need to look at f of g of x is a composition of two functions, although we're ending up x minus 5. That's one thing is important. All right, what was the other part of the question? Okay, we've done a g of f of x. Okay, let's have a look into that. So g of f of x. So it will be g, f of x was x squared. So what will it be? Well, what is g doing to x squared? So it is going to take it to something like that. So this is g of f of x. Now, again, we need to go back and think. Does inside function x squared has any limitations in terms of domain? No. Okay, inside function has no limitations, has no restrictions. Okay, so then we can go here and directly look up what's happening there. So what will happen there? X squared minus 5 again should be greater than equal to 0. Why? Because we are inside the square root. Okay, so then we should be looking at x squared should be greater than equal to 5. All right, so how is that going to happen? So we need to find the roots of x squared minus 5. Make it equal to 0. So x1, 2 will be equal to plus or minus square root of 5. All right. So you might want to think this function as a quadratic function also. So it's a parabola upwards, and the roots are like negative square root of 5 and positive square root of 5. And what you want this parabola to the positive sides. Okay, so we don't want x to be between negative square root of 5 and positive square root of 5, and the way we are going to write down this domain, negative infinity till negative square root of 5 union square root of 5 to positive infinity. I made a mistake here, so I need to include those. Okay, so that will be the answer of domain of Goff. All right, so this was that, it was here, it's asking f of f. Now we're going backwards there. And what was your next question? Let's have a look again. Sorry. Question 1. And the problem number 2, division of f of g of x. Okay. So problem number 2, division of f of g of x. Okay. Let's have a look. So this is number 2 now. In number 2, our f of x is x squared plus 2x. Our g of x is 8 minus x squared. Okay, so what are we looking at now? F of g of x. What is that? First let's cite that. So it will be x squared plus 2x divided by 8 minus x squared. Okay, so this is our f over g of x. All right, because we do have a rational function, we are interested in the denominator. When we look at the denominator, okay, we see that 8 minus x squared cannot be equal to 0. Okay, it's not greater than equal to 0. It cannot be equal to 0. That's my restriction now. It's not that. No, not this one. Why? Because this one, I use it in square root. I don't have any square roots here. So it cannot be equal to 0. Probably you have a different problem than me, Cassandra, so be careful. I think you should have 7 here instead of 8, but you will be using the same technique. So then it can't be equal to 0. It means that x cannot be equal to square root of plus or minus square root of 8 if you solve that equation. So what does that mean? Domain will be negative infinity, negative square root of 8, parentheses, union, square root of 8, new, negative square root of 8, positive square root of 8, union, square root of 8, positive infinity. So what we want to say here, if you want to show it on a number line, so we want to get every number but except these two guys. So we're coming from negative infinity, positive infinity there, if that's the number line, like this is 0 here. Okay, so we can include everything in this line except these two guys. So we're coming from negative infinity till negative square root of 8, union, we're getting in the middle part, union, and we're getting to this part. All right, hope it helps. Let me know if you have any questions. Bye.